You're not doing anything. Stop. Not doing anything. I just want to feel something.
Good morning, everyone.
Morning.
Good morning. Man, we've only got 5 people. We'll wait a few minutes and see if anybody else comes on. Well, I did buy me a stylus over the weekend, but it doesn't necessarily work very well either. So we will get through this one way or the other. I believe everybody could do the warm up here. That you make sure to. I'm sure everybody can see my screen. Osas, do you see warm up there?
Yeah, I see it.
Perfect. Okay. Sorry. So this is just the, did it, by the way, before y'all came into the room, did everybody pick up the sheet by the door, the formula activity from the table by the door?
Yes.
All right. Thanks, Leslie.
Are you being sarcastic?
Yes, because at the bottom of the screen it says, please pick up the Pythagorean theorem and the distance formula activity from the table by the door. I was just joking. Man, Monday mornings are rough for everybody, huh? All right, so anyway, we'll just get to the lesson then. So here to find this, we just say 6 squared plus 8 squared. See, this thing is horrible. 8 squared is equal to, so 6 squared plus 8 squared is equal to x squared. 36 plus 64 equals x squared. 36 and 64 equals 100. So equal to x squared. We take the square root and we get x is equal to 10. I think we know how to do these. These are not that difficult. And over here, it would just be the reverse. We would see 24 squared plus x squared is equal to 26 squared. And I don't have a calculator in front of me, but we know that if we just subtract that 24 squared from both sides, take the square root, and we will get this. All right, so that's not that difficult. Find the possible B values. I can't believe this is a warm-up. Let's skip over that because I want y'all to watch this for me. And we're only going to cover today, the distance portion of the keeper because it'll take too long for us to get into the midpoint. So today we're just going to talk about distance. And let's watch this YouTube video, which I've already have pulled up, just to make sure we understand. I tried to explain it last week, but let's try to make sure we understand how the distance formula came to be. I think I go here and here. Nope. The distance. All right, here we go. Can y'all see this
some
video?
X coordinate and some Y coordinate and some other X coordinate and some other Y coordinate. 2 points. It says the distance between them. It says we have to take x2 minus x1 squared, y2 minus y1 squared, add it together and take the square. Notice since both terms are being squared, it doesn't matter the order.
We're not going to hear anything.
So let's just talk about where the distance formula comes from real quick, because I think that's a good way to help, maybe somebody do it, and then just do a simple example with it. So, okay, I've got my 2 points here labeled generically, x1 and y1. There's one little dot, x2, y2, so there's some other little dot, and we just want to know that straight line distance. Well, notice we can make a little right triangle in here. Okay, so if we make a little right triangle, so forgive my artistry, now we can think about using Pythagorean theorem. So if I call this side A and this B, normally we use C, but let's use D for distance. So Pythagorean theorem would say A squared plus B squared equals, well, D squared in this case, but we can actually figure out a numerical value for A and for B. Okay, if I'm already at the x coordinate x of 1, and I go over to the x coordinate x of 2, that horizontal distance is going to have value x of 2 minus x of 1. Okay, so that length A is going to be x of 2 minus x of 1 all squared. And likewise, B, that's going to be the vertical distance, which is going to be the difference between the y coordinates. Okay, imagine this y value is 10, this y value is 2. Well, the length would be 8, 10 minus 2. So B would have value y sub 2 minus y sub 1 squared, and that's going to be d squared again. Well, to solve for the distance, to get rid of the square, we simply take the square root of it all. So that's where the distance formula comes from. It's just labeling things and using Pythagorean theorem. Okay, so maybe let's plug in a couple specific points.
We don't need to plug in points because we are going to do it on our own. I don't know if can y'all see back to seeing my screen here. Do y'all see that?
Yeah.
All right. So this is where we were at here. We already watched that. So this is the distance formula. Here is another formula you will have to put to memory. And we just saw how we got that formula, where it comes from. So this is what we're going to talk about today and do a few problems. So if we found the distance between the following, how would we do that? Well, we would just put it into our distance formula. So it's asking for our x2 minus x1. And like he said, it doesn't matter if this is the 1 and this is the 2 and this is the 1. It doesn't matter because we're squaring it. And when we take a square root of anything or square anything, we know that it becomes a positive. So we just need to just label what we have here. This is x1, this is y1, this is x2, this is y2, okay? And then we just say our distance will be equal to the square root of x2 minus, so x2 minus -1 squared plus y2 -3 minus 6 squared. So D is equal to -2 minus 1, or 2 minus 1 will be 2 plus 1, so that's 3. 3 squared is 9. 9 plus -3 minus 6 is a -9. -9 squared is 81. So D would be equal to the square root of, oops, that's a little long there. I don't need it to be that long. The square root of 90. And actually the square root of 90 can be simplified as 3 times the square root of 10. And that would be our distance, 3 times the square root of 10. So this is just a plug and play type of lecture. Does anybody have any questions about how I got to that? All right, let's try another one. Now we are given a distance and it's asking for what is this coordinate? What's going to be our B value there? Again, we can just say that this is x1, y1, x2, y2, okay? So now we just set it up to say, well, 7 is equal to, okay? So x2, that's going to be b minus 5 squared plus, over here we have 8 minus 1 squared, right? All right, then we just keep working it on down. 7, that's a long 7. We call that 7 to infinity. That's b minus 5 squared. So this is where we have to do a little bit of factoring, our FOIL method, right? So that's going to be b minus 5 times b minus 5, right? Do we need to do that here? So this will be b minus 5 squared. Give me a second here. B minus 5 squared. Now plus, what's 8 minus 1? That's 7. 7 squared is 49, right? Okay.
Mhm.
Let's hold this for just a few minutes, okay? Now, we know that from this point, it's going to be very difficult to solve if we don't figure some mathematical way to do it. And the only mathematical way I can think to do that is to square both sides, okay? Because we're trying to get this, take the square root sign away. So what I want to do is I want to square this, and whatever I do on one side, I have to do on the other. I square that. And now I get 49 is equal to b minus 5 squared plus 49, okay? Okay, does everybody see that?
Mhm.
Now let's come back up to this guy right here. This will be b squared minus 5b minus 5b plus 25, okay? So now we just rewrite it to say 49 is equal to b squared minus 5b plus 25 plus 49, okay? Now, if I was to subtract 49 from both sides, right, I'm going to get b,
Mr. B,
huh?
is that not supposed to be negative 10b?
Oh, yeah, it should be. Yeah, you're right. Sorry, Osas. Good catch. 10, okay? So now I have b squared minus 10b plus 25 because the 49s go away. Okay, now I'm right back to the problem we have, right?
Mhm.
So what do you think b is going to be?
Factoring.
Yeah, we just factor it. B minus 5 squared. Take the square root of that. B is equal to 5. So b in this case is equal to 5. See how easy that was?
Yeah. Well, you have to go through all the like factoring stuff.
Yeah, we're going to go through another one that's just like this. Now, every time you do this, it will not come right back to what it was originally, okay? Just in this one, in this case, it does. And in the next one, it does. But this is how we do it. Let's try another one. This time, we're looking for x1, y1, x2, y2, and we're given our distance already. So I've got 6 is equal to the square root of, open parentheses, 2 minus, it doesn't work very well when I do a 2. 2 minus b squared plus negative 2 minus 4. Negative 2 minus 4 squared. Okay.
Mhm.
So we still have 6 is equal to, do this little thing again, 2 minus b squared, okay, plus negative 2 minus 4 is a negative 6, right?
Yeah.
Negative 6 squared is a positive 36. All right. Now, does this not look, if we go, can I go back one? Yes, I think I can. Does this not look exactly like what we have here? See how we got a
Yeah.
7 squared with the 49, the square root of 49? So what?
Yeah.
So you can see right offhand that we might get the same exact thing as we did. We might get our distance of 6 as b. But let's continue on. So again, how do we get rid of the square root? We have to square both sides. Okay. When we do that, we get 36 is equal to 2 minus b squared plus 36. Okay. Now 2 minus b squared, if we write this out, will be 2 minus b times 2 minus b. Okay. It's going to be 4 minus 2b minus 2b minus b squared. Okay.
Mhm.
Which that just turns out to be 4.
Wait, wouldn't it be positive b squared?
Yes, that's right. Positive. Good job.
Oh my
4b plus
God.
b squared. Okay. So it's important to always get your sign right. That's good job. All right. So now if we rewrite this to say 0 is equal to,
It's not got it.
0 is equal to b squared, b squared minus 4b minus plus 4 plus 36 minus 36. Maybe we don't get the same thing. Anyway, these will cancel out. We will rewrite this to be 0 is equal to b squared minus 4b plus 4, which just becomes b minus 2 squared. We take the square root of that. We get b is equal to a positive 2. So it wasn't just like the other one. B is equal to a positive 2.
Okay.
Now, if you was to plot this, you could see how that would work. Let's try to plot it. So we got 2, 4. So 1, 2, and then up 1, 2, 3, 4. 2, 4 right here. And then we got 2, negative 2. 2, negative 2. Okay. And there's a distance of 6. Well, 1, 2, 3, 4, 5, 6. That's our distance between them. All right. Let's try another one. What about one that has something that looks like this? Square root of 73. Well, we still do it the same. Is there any taker out there who would like to try this one?
Nobody.
I know. So out of 31 people we have in our class, 9 of us show up. Thank y'all for showing up. I appreciate that. Well, since there are no takers, I guess it'll have to be me. So here we have X.
Let me do it actually.
Okay. All right. Good. I'll give you a few minutes. Do you want to control the screen and do it?
Yeah, you want to write it down and I just say it or something?
Yeah. Why don't you write it down and say it?
No, you
Oh, okay.
like you.
All right.
Okay.
All right.
Thank you.
X1, Y1, right?
Yes, then x2, y2.
Okay.
So now I do so I'll say the square root of 73
Square root of 73.
equal, then I have, so I'll say -8. I'll put like the square root
That's right.
sign like the other. Then
Perfect.
I'll put parentheses. Then I'll say -8. -8 plus 0.
Minus 0.
Minus 0. Okay, minus 0. Okay, minus 0. Then square it. Then I'll say plus. And I'll say b minus 4
Squared.
squared.
Nice
Okay.
job. All
So
right.
now this is gonna be, so say the square root of 73 equal, this should be -8. So say the square root. So the square root, then say -8.
That'd be what square root of -8?
-8, so that would be 64.
Yep.
So this
Plus
shoot.
this, which is b.
So this one is going to be b. Let's just factor it right away. Can we
Nope.
just factor?
No, don't factor it
Okay.
right away.
Okay. We'll just find them, square both sides.
That's right. So square both sides. Yep. And we rewrite it.
And this square cancels this. So this becomes 73. Then this this cancels this. The square cancels that. So we have the squared for that part.
Perfect.
Then we could, I think we just subtract 73 first.
Well, what I like to do is I go ahead and I get this guy and I go ahead and rewrite
Okay,
it.
I'll do that then. So say 73
Okay, 73
equals 64. Then I'll say plus b squared -8, then positive 16.
Right.
-8b, then positive 16.
Perfect. Now we can
So,
subtract 73 from both sides.
on both sides.
Now, I don't have a calculator. Well, I do. Let me see.
Well, I think that should be 9, -9.
So 64 plus 16
Oh, plus 16. Okay.
minus
That should be
73.
80.
7.
That should be 7.
That's
Kinda.
right. Yep, 7. So that's going to be equal to 0, right? And that's going to be b squared minus 8b. And let me just make sure I did the math right because it's a Monday morning. 64 plus 16 is 80 minus 73 is 7. That's going to be plus 7. Okay.
So we say 7. So put the parentheses. 7 plus 1. I think it's 7 and 1 that will go.
That's right.
Wait, no.
So it'll be, yeah, you're right.
Yeah.
B.
Yeah, 7 and 1.
B minus 1, right? And B minus 7, right? Is equal to 0. So we actually have 2 possible values for B. Nice job, Osas. We have 2 possible values for B. We have B could be B is equal to either 1 or 7. Either one of those will get us to a square root of 73. All right, here's another one. Now, this is the midpoint formula. I'll do this last one here, but I actually wanted to cover the midpoint tomorrow. Before we actually get into we want to make sure we understand the distance formula first, which I think we're getting it. It's not very hard. Before we actually get into the midpoint formula. So the same thing here. We have 2 times the square root of 5. It's going to be equal to all of this. And this is our x1, y1, x2, y2. So we're back to just plugging it in. So that's 6 minus 2 squared plus y6 minus b squared. Okay, so we just rewrite it. 2 times square root of 5 is equal to 6 minus 2 is 4. That's squared is 16 plus 6 minus b squared. We take the square root of both sides. Okay, squared here. Now over here we're going to have, when you take the square root of 2 times square root of 5, you're actually going to get 5 square root of 5, square root of 5. That's just 5. Okay. And then that's times 4. So 5 times 4 is 20. Okay. Does everybody see how I got a 20 there?
Yeah.
Okay. Let me know if you don't. And this will now just be 16 plus 6 minus b squared. All right. Now 6 minus b squared, we rewrite that. 20 is equal to 16 plus b squared. Okay. I like to put my variable first. Minus 12b plus 36. Okay. Now we subtract 20 from both sides, minus 20 from this side. And we get, so let me just go ahead and do this. That's 16 plus 16, right? 36 minus 20 is 16, plus 16 is 32. So I get b squared minus 12b plus 32. Now, how do I factor this? Well, I got to find the factors of 32. That'll get me to 12. 8 and 4, right? 8 and 4 would be it. So I have b minus 8 and b minus 4. And this one also has two values. B can equal to 8 or 4, sorry. And that would be my solution set. B is 8 or 4.
So the factors have to add up to 12. They can't multiply.
No, because it's the FOIL method. You take, just like, it's just an order of operations. B times B gives us B squared. And then B times negative 4 is negative 4B, right? And then right here, that's 8. Negative 8 times B is negative 8B. So negative 8 or negative 4 minus 8 is negative 12. And then negative 8 times negative 4 is a positive 32.
Okay.
So you have to get your quadratic equation here and then factor it. And then you'll get two solutions. All right. Well, that was distance formula today. Does anybody have questions about it? Tomorrow we'll cover midpoint formula. But as of right now, I just wanted to make sure you understood how to do those. I'm going to be sending out a USA test prep link.
No.
Just a review on circles. And make sure that you guys remember how to do those. And you should be good to go.
Are you sending it today?
Yes. Yeah.
Oh, Lord.
Yeah, you'll have a couple of days to do it, though.
Okay.
I really just want to see how we did remembering circles. All right. Well, that's all I have for today. Any other questions?
None.
All right. All right. Well, thanks for showing up, guys and ladies. I'll talk to y'all later.
Yes, sir.
All right. Bye-bye.
Bye.
Bye.
Good head.